Okay, so last time we started talking about generics. I'll try to finish that quickly. That one just more like a slight extension to polymorphism, dynamic binding. Again, for those of you who took 2030 with me, I didn't quite go over this slide, so it would be something new to you as well. Okay, anyway, we should really review that. And then we talk about a interesting design pattern, which will be related to your projects. Okay, so we can have discussion today. Okay, about generics, so that's the code that we talked about last time. Okay, let me, I assume you have seen this already, so let me just go to the iPad again and see why having a general book to begin with is not so good. Let's understand the story over here. Okay, again, I want to highlight the things you really notice. Number one, you can see for the book, you have any for the record type, and also you got any over here, you got any over here. So whatever you put in to the book, it can be anything. At the same time, if you want to retrieve something from the book, it can also be anything. It seems to be very flexible. However, as we try to analyze deeper, it's going to violate single choice principle quite badly. So that's something we want to learn today. Okay, so for those of you who need a little bit of brush up, I just mentioned that line number 8 over here is not going to compile. Okay, every time we talk about compilation, the only thing you should care is the static type. That's the only thing. Okay, let's have a quick look. As Jordan pointed out last time before the class, when you look at b.get, even though you knew that for Yuna specifically, we actually put in her birthday into the book, but birthday is only the dynamic type. It's not a static type. That's the object we store into it. Okay, so what you will see is for b.get, as far as the compiler is concerned, they're going to see the get feature over here. Its return type is simply just any. Okay, so that means this part over here is simply just going to give you any. So now the question is, does get day of the week, which is date-specific feature, does it exist in any? No, it doesn't. So that is why it's not going to compile. If you think about it, any is like the object class in Java. Okay, nothing new. Under any, we actually got a class called dates. And then for the date, we got this particular get day of week feature. That's only available in the date class. However, the static type is any, so it's not available. Okay? Now the question is, if we are so sure that b.get Yuna is going to return a date objects, what should we do? Cast, exactly. Okay, so now let's do that very quickly, and then we'll see how the design principle may be violated. We want to see that. Okay, so now let's see. Okay, so that's more explanation. Okay, I already said that, so I don't need to trouble you with that. Okay, how do we do the cast? Okay, just remind you of the syntax over here. You just want to make sure Yuna, whatever b.get Yuna static type is any, we want to cast that into dates, and then we can try to use it. Okay, that's something you already knew. Question for you. What if I try the following? Okay, let me just do this. Let me write it out over here. So now considering the same code, I'm just going to write something over here. I want you to tell me two things. Number one, should I compile? Number two, should it give me any violation at the runtime? Okay, two questions. I'm going to write it down. Imagine that after line number 8, I'm going to have this. Let me use blue. Okay, after this. What I would say is, I'll say check attached. And then I'm going to get, I want to cast also into dates. What I want to cast this time will be b.get. And then I'm going to say Suyan over here. Okay, that's a name, just the other name. S, okay, I would say D over here. And then end. And then I would say is Wednesday is assigned to b.get day of the week. Okay, I'll just write it a little bit simpler. All right, so now could you please consider this cast? kind of similar to the cast we want to do in order to fix number 8. Okay? So 2 questions for you. Question number 1, should it compile? Number 1, compilation. Actually, you got several things over here you have to decide as a compiler, right? Let me break it down for you. If you only consider this part here, just about this cast over here, this cast alone, should it compile? Yeah, remember for cast, always compiles. Always. That's not a problem. What about this line over here? I meant to write over here, beg your pardon. I meant to write D over here. Sorry about that. Okay, and then what I will do is highlight this. Do you think this line should compile? I heard yes. Good. The reason is, okay, in case you don't know, because D was the local variable I just introduced of type static type, dates. As far as the compiler is concerned, it's going to tell me D static type, which is dates, does have this get day of week defined. So that will also compile. Compilation, no problem. Okay? Second question. Are we going to get any runtime violation? Okay, I heard yes. Good. So now, can anybody explain to me why? Yes. Oh yeah, of course, absolutely. Yeah, I agree with you. Let's be precise. Okay. If I say that's 4, okay, no problem. Okay, so now, anybody want to explain why it would be a violation? Please.
Because the other parameter is phone number, which is not of type date, and it does the phone number.
Exactly. So basically, somehow we have a polymorphic collection. If you think about it, let me just draw a little bit more detail. Right? You want to think about the example more carefully. You can think about we got B of type book. And the book itself has 2 attribute names and records. Names and records. Okay, 2 arrays. So here we got the first name will just be Suyang, I'll say S, and then Y for Yuna. And now for the records array of type any, right? For the first one, we actually put in the phone number, which is string. Okay? Over there, that one is simply a string. I'll say S for string. And then the second one is actually a birthday that we put in, which is here, right? Birthday over here. So that one there is a date objects. So this is exactly polymorphism. So the static type for every element of the array is simply any. But dynamically, it can be a string, can be a dates, etc. Okay? So now, when you actually say this guy here, b.get Suyang, you're going to return, sorry, let me say it again. b.get Suyang over here. Suyang is actually the first one, the first name. The corresponding position will give you a string objects. Can a string object satisfy the date expectation? No, it cannot, right? So that's why you will get a violation at the runtime. Yes, you'll get violation. It compiles, but it will give you a runtime violation. So this is, again, not really something new. I want to just bring a little bit of review, okay? So every time you have a cast, you want to know, it always compiles, but when does it really have a violation for you at the runtime? Okay? Yeah. Any questions? Okay, if no, let's now talk about a little bit about more design. Why is a general book not good? Hints for you. Every time, if you want to judge if your design is good, not just for the project or this course, beyond this course, if you want to judge for your design, it's not just for the current functionalities you have to implement. Think more about what about the future, because the project may have to live for a long time. How do you, when you want to extend with more features, when you want to maintain it for any bug fixes, is it going to be easy for you? If it is easy, it's a good design. If it is quite tedious and manual work and many places to modify, then it's a bad design. Okay, that's a more general principle for you. So now, can anybody actually see problems for this particular design here, where a record is simply just any, the static type? Jordan?
I do a lot of testing to see which type it is. Every time you essentially wonder if it's a date, wonder if it's an
Exactly. That's exactly right. Let me rephrase it there a little bit and make it a little bit general. Basically, the bad thing about this design over here, for now, we only store dates and string into the array. Just for this case over here, we already have to distinguish between the two possible dynamic types. If it is a date object that's being returned, cast that into a dates. If the return object is string, cast that into a string. So now let's make it more general. Okay? So now let's imagine this, the following. Okay, I'm just saying some example. It could be account, can be array container, can be repository, can be array heap, right? Many things. So now all of them, as long as they are descendants of any, is acceptable. Now I want you to imagine, let's say we got 100 different kinds of objects we want to store into the book, which is totally fine. Okay? And now let's see this. I'll show you a little bit and I'll do some illustration for you. Let's just for illustration, let's imagine that you got 100 different classes. They have nothing to do with each other. You got C1 being a class, C2, C3, up to C100. You got 100 different classes. Okay? Can all of them be added to the array of records? Yes, because by default, every class should be a descendant, right? So now let's say this. We create an instance for C1 and then add it to the to the book. And also for C2, for C100, etc. So what we get is something like this. Of course, the order doesn't have to be this way, but just for illustration, let's say if this is my array, you can think about basically different position 1, 2, 3, all the way to 100, right? Maybe this one is pointing to dynamic type C1. This one is pointing to dynamic type C10. And this one is pointing to maybe C87 and all the way, right? Simply when the order is kind of random, you just don't know. So now, the question is, let's say you are the clients of this particular book. You're returning some, let's say I'm returning some objects from the array. Again, let me redraw the array, okay? All the way to 100. If I simply say now, give me the object back in index I, can I know for sure which dynamic type it is? Not necessarily. There are 100 possibilities, right? So what I have to do is to have some if conditional check to say if it is dynamic type is C1, I do something according to C1. If it is of dynamic type C87, I do something according to 87 to see what features we might have. Okay, let me show you. What you end up having is something like this. I can say if, let's say I simply say b.get Jim, let's say. Jim is the name. And then the static type for b.get Jim will just be any. Now I want to cast that into C1. And then assuming that C1, sorry, this is some typo over here. Let me just show you how I should write it. Sorry about that. Okay, so what I meant to write is this. Okay, let me just fix the typo for you. So if you can look at this part over here, right? Okay, C1 dot F1. Assuming that F1 is a feature specific to C1, let's assume. Okay, so now you can say this is any over here, under which we got C1, which got F1, and also we got C2, which got F2, and all the way to we got C100, which got F100. Let's say, to make it symbolic. So now I can only call C1 F1 if I know that C1 can be cast into C1. Agree? Okay. And this is one instance of the exhaustive check. If I want to retrieve something from the array. Basically, every time in your client's code, if you actually want to get something from the array and do something specific to that dynamic type, you have to repeat this particular if statements, right? So the reason that I show you two repetition over here, you can think about this is repetition 1. And this is repetition 2. So they simply occur in two different places in the client's code. They simply repetition. So now, let's bring back to the focus. What if I gave you two questions over there? Okay? Let's see the first one. What if a new type, C101, is introduced? So far, we only got 100 data types. We want to introduce one more. How many places do I need to change 1 or more than 1? More than 1, right? Can you imagine how I'm supposed to do it?
You have to add another if check.
Yeah, you're going to add another else if check, right? Because you can think about the pink and orange are simply different places in the client's code. Because every time you get something from the array, you only know it's any. So you want to have an exhaustive check. Okay? So now I'll just do this one for you. So let's say, what if a new type C101? So what you will do is, for the first one over here, you're going to say else if, and then attached. And then you're going to say if it's C101. In that case, finish that, and then do something specific to 101. And then you got to do the same thing over here to say else if attached. And then you say C101 over here, and then you do something specific to 101. So 2 places. But so here I'm only showing you 2 repetitions. What if you repeat it 10 times? I want to modify 10 different places. Okay? That's when you do extension. Let's say another scenario, which is also very common. Let's say, what if over here, if C100, it turns out we don't need that class anymore. We simply right-click on the class and say delete. In that case, what should we modify over here? Yeah, kind of the opposite operation, right? So that means we have to, first of all, delete this particular branch over here, because C100 is no longer in the system. Delete that particular branch once, and also delete this the second time for every occurrence of the such cast. Okay? So these 2 scenarios, either introducing a new class or deleting an existing class. These are very common issues you're facing. A good design should not be very, how to say, a good design should really allow you to obey the single choice principle. Only a single place to modify, not really multiple places. Okay. It's a little bit abstract, but we'll see this again. Okay, but to convince you about a motivation for generics, that should be enough. Okay, guys, any question about this? If you got confusion. Okay, so very important for you to know, it violates the single choice principle. Okay, that's number 1 important. Now, how can we fix it? Okay, how can we have a solution that satisfies the following criteria? Let's see. Let me just go over some slides very quickly, and then we'll talk about solution. Number 1, we don't want to have any cast. Furthermore, even if we have a cast, we can have some runtime assertion violation, right, as we saw. We want to have nothing like this. Okay? No cast, no runtime cast exception. And number 2, we want to make sure we don't have to violate the single choice principle by having so similar if statements everywhere in our client's code. So these are the 2 criteria. So now, how can a solution solve both of them? Generics. Okay? So now let's see how exactly it's going to happen. Okay? So I'm going to make it quicker. So we don't need to, you can read the slides. Okay? I'm just going to illustrate to you how the generics is going to help you. Okay? So now let's go to the generics solution, a generic book. You have to think from both the point of view of a supplier and also the clients. Okay, we're going to see both. Okay, from the supplier's point of view, all you got to do is this. One more thing I want to draw your attention to. When you see the slides, you will see a particular one over here, just about what are parameters. Okay, that's something you can go over as well. I'll explain to you on the iPad now. Okay, just to save time. Let's say if you try to define a method in your, or feature in your program, okay? Let's say if I say deposit, okay? Deposit over here, and then I can say amount, and then I have, let's say, real number. Okay, let me ask you this question. By having this amount being a parameter, what's the use of the amount over here? As soon as I declare this particular parameter called amount, what it allows me to do is to refer to whenever any clients or any user or caller try to call this particular feature by passing some specific value. For example, let's say at the runtime in the client's code, if they simply say maybe accounts dot deposit, and then 23.4, for example, right? So this is one case, in which case this particular amount will be instantiated using 23.4. If another client simply say deposit and then with a different value, maybe 46.8, in that case we'll use the amount as 46.8. So a single block of code can solve many instances at the runtime. So all you got to do is to make sure inside this particular deposit, all you got to do is to refer to amount, which means whatever amount that's being instantiated into by the caller, you're going to use it. Okay? Amount, you can say balance is assigned to balance plus the amount. Okay, that's parameter. Okay. Now, generics basically takes this particular idea over here, also for parameter. That's why I want to draw you some connection for you. How do we understand it? Okay. Any question about parameter over here? That's basically from your Java courses. Okay, but that's true for programming in general. Now, let me go back here. If you look at the generic parameters design, okay, every time I call the G over here, the generic parameter. So let me highlight it. The G over here is called the generic parameter. The reason that it is called a parameter is because it can be used by the scope of the current class, which means the records over here can make use of G. Okay, let me use a different color over here. The record here can make use of G. And also you can see over here, the parameter type can also make use of G. And also the G return type can also make use of G. Okay, so now you can see, I want to say that again. So these are the use of parameter G. Okay, remember when I first talked about generic parameter as a usage, right? In the beginning of the course, I said you should really distinguish between this very first one, which is about declaration of the parameter, and all the others in the same class should be about using the generic parameter. Okay? So now, one more thing to say. When you talk about parameter for your feature, you're only talking about this is parameter. Here, the parameter denotes a value. Okay? It can be 23.4. It can be 46.8. What about the parameter over here? Does it denote a value, though? What does it denote?
It could denote a value, an object. It could denote anything.
Well, can it really denote a object, though? Are you trying to say, OK, let me make my point clear. Okay? Let's say this. Let's say I have a client code. Let's say I have some local variable. I simply call that, let's say, ACC, accounts. Okay, let's assume account class is there. And then over here, I say B is of type book. Now, can I say the following? Since you say it can be the value of objects, can I say ACC over here? Well, ACC apparently is the value of some objects of type account. Can I say ACC here? Apparently, I cannot, right? So that's exactly what I was trying to ask. When I declare the G over here, what does G denote as a parameter? Denote some type, exactly. That's why people say it's a generic parameter type. Okay? So now generic parameter over here, so I'll complete this. Generic parameter denoting some type, not value. Okay, so ACC is not good over here, right? Okay, just to clarify. In the case of feature parameter, yes, it is denoting a value. In the case of generic parameter at the class level, it's denoting a type. So that means any clients who's actually trying to use the book class, they have to commit to a type. Okay? Yeah, just one moment. Let me say something, and then we'll get to you. Now, if you look at the client over here, let's say B over here, I say book, and now date is actually a type, right? Date is a type that instantiates G of book. Okay? So now that means, I'll get back to you just one minute. Okay? So that means as soon as you say, I'm going to instantiate the G over here as dates, that means every occurrence of the use of G over here is going to be dates. Okay? This is something we did previously, but now hopefully you can see a little bit even more. Okay? Just date over here. Yes, you got questions? Can you use the like in where? The book? You mean, oh, you mean to use, okay, maybe something like this, I guess. Okay. Conceptually, I can see what you mean. Let's say local over here, and then let's say ACC of type accounts. And then we got B of type book, right? And now we have to give a type to instantiate parameter. What you're asking is, can I say like anchor type ACC? Is that what you're asking? Good. I believe you can, yes. Yeah. Yeah. So this has the advantage that if later on, if you decide to change the type of this, you'll modify this automatically, right? Okay. Okay, so now that'll be it. So now, can you look at this new design over here? I want you to consider, after we have got this particular line committed to the date type. Yes, question. Oh, you mean over here? Are you asking me the following? Class, and then let's say book 2, for example, different class, right? Can I say like a like over here, and then, for example, ACC, right? Okay, good question. The answer is you cannot. Think about this. This guy here was okay, because ACC is referring to some existing variable. But you're only starting to declare a class. Is there any variable in the context for you to refer to? The answer is you cannot. Okay, so this will not work. Good try. Remember, at this level here, inside the square brackets, your purpose is simple. You just want to declare some generic parameter type, just that. Yes, exactly. Yeah, let me say a little bit more. So now let's say this. If I say that class and then book, if I only say G, so that means anything can instantiate G. However, if you want to restrict a little bit, if I say the following, okay, let's try this. If I say G like that, so dash greater than, you have seen this in lab 2 already. What if I say students? So that means any class can instantiate this G as long as they are descendants of students, including students itself. Okay. Guys, make sense? Okay, good. That's about generics. Okay, so now can you look at these lines over here, and I want you to tell me after we have done these. Okay, can you tell me which line is not going to compile? Previously, let me remind you, previously, in the case of the general book, line number 8 is not going to compile, right, as we explained. But what about the new design over here for generics? Do you think this line will still compile, this line here? Do you think that will compile? The last line. The last line did not compile in the previous design. Should it compile now? I heard yes, but let's see why, first of all. The critical thing is, what would be the static type for b.getUnit over here? So now we talk about B specifically, and B has instantiated G for dates. So that means when we look at the get over here, G would have been replaced by dates already. So now we really talk about static type being dates. So that is okay. However, it's even more important to realize why retrieval right now can be so safe without a cast. It is because we got more constraint on the insertion. Okay, so now can you tell me, is there any line before the last line is going to stop compiling? Okay, I should have put number. Yeah, should have. Can we say this is, let's say this is 1, this is 2, this is 3, this is 4, this is 5. We said 5 is going to be okay now. Okay, which line is not going to compile? 2, exactly. Okay, let's see why. first of all, you can see that phone number over here is of type string. Okay, phone number is type string. However, what is the expected type from the parameter? If you look at the add over here, we talk about context object B specifically, and G has been replaced by dates. So now that means you can only add in record of type dates. Okay, so now string does not match date, so it wouldn't compile. Are we okay? So a typical exam question, typical one. I'll give you something like this, a very typical one. I'll give you this initial design and ask you to tell me which line wouldn't compile, and then explain why, number one. Number two, I will ask you how you can improve the design using generics. 2.1 actually, 2.2, explain why single choice principle will be violated by the first design, right? Question number three. Once you improve the design using generics, tell me which line will compile and which line wouldn't compile and explain. Okay? That's kind of an exercise your understanding. Any questions? Yes. What? It is possible, yes. For example, let's say this. Let's say B2, book number 2. Book, and then over here I simply got students. Okay? What this will do is like this. Let me be very precise over here. Okay? Imagine that what this will do is it's going to instantiate the G over here by students. Consequently, every occurrence of the G over here will be replaced by students and students. And now we are basically back to our lecture last time about feature arguments and also return value being polymorphic, right? Basically, okay? Let me just give you one example. Let's say this. Now, if I have, let's say, S1, S2 of type students, okay? And then I say creates, and then resident students S1 dot make something, okay? And then I can say creates non-resident students S2 dot make, and then with some argument over here, okay? So now if I say B2, okay, this guy here, dot add. I might say, for example, Jim over here, and then S1. Would this compile? Question for you. Would this compile? How do you see? Static type, right? Okay, I'll use S1 has the static type students. What's the expected type for this parameter? Students has just been replaced. You can see just one extra step to do compared with before. Okay, so that one's fine. And then we have B2 dot add. And then let's say Jeremy, and then S2. Would this compile? Yeah, for the same reason, okay? So that one I wouldn't bother you. So now what's going to happen is B2 is now pointing to book. And then we got names, we got records, okay? And for the names, we got Jin, we got Jeremy, right? And now this array will be polymorphic. Would you agree? In the sense that this is going to point to some S1, and S1 is pointing to some resident students objects. So resident students. And then S2 is pointing to some non-resident students objects. Non-resident students. So they're just different type. One is resident student, the other one non-resident students. So that's polymorphic. So everything that we said from last time still works. But now the good thing is, using generic parameter, as soon as you commit to the type for G as a client, it will fix for you. Okay? Any question, please? I'll take you first. Yeah.
So I know for generics, we can store anything that's like a descendant of the object.
Of the type that you instantiate into, yes, correct.
But, like, let's say for the previous example, we had phone numbers and birthdays, which
Mm-hmm.
are not like related. Is there a way to like store them?
Yes, that's a good question. From this particular example over here, what you have is students. That means any descending class of students should be able to be stored. Okay, let's think backwards. If you have two types, let's say string, and also you got dates, for example. They have nothing to do with each other. Now, is it possible to got B3 over here, and then we say book? And then to put something here such that it can accommodate both string and dates. That's what you're asking, right? Guys, any thoughts? Well, exactly. Well, what you said was right. Common ancestor. Basically, and to be a good, you want to find the closest common ancestor so that you don't really be so accommodating. But as I said before, these two classes have nothing to do with each other. What will be the common ancestor? Any. That's the only choice. The only common ancestor between any unrelated classes will be any. And then you simply put any over here. And guess what? We're back to the first design. So if you had to do this, you're wasting generics. You're wasting. Yeah, that's not good. So that will actually force you to reflect. Why would you want to store string and dates in the same collection, right? That shouldn't be the case. You want to store something that's related in the same collection. That's, for example, yes, that could be maybe one book for the string, one book for the dates, possibly. Yes. Okay, good. And you can see as soon as you do this, you're going to do all the kind of casting, right? That's the problem. Yeah. Okay, so now let's go over a little bit more. Okay, we're almost done for generics. Okay, observation, you can look at that. Okay, it's just about instantiation. For that one, you can already cover. Okay, well, that's exactly what you're asking. That's good. Okay, so now, do you think this might be appropriate choice now? No. Okay, please don't write this in your code. If you do that, that means you haven't really grasped the understanding yet. No. Okay. The reason is you're going back to the original design, and then you're going to need lots of if then else and checks and cast. That will violate single choice principle. Okay, you just go back. Okay, exactly what I just said. Okay, so now I want to do just one more exercise, and then we are a few more diagrams, and then we are done. Given that you have done lab number 2 already on the generics, this one should be a piece of cake, I'm pretty sure. But let's do it anyway. It's on the slides. Can we say now we have a dictionary class where we got V and K. Okay? V for values and K for keys. V and K can be instantiated to any types as you wish. Okay, we got add entry, we got remove entry, right? We just got V and K, just use them. Okay? So now what we want to see is, let's say we have another class over here called database table. However, when I define this class, I don't necessarily want to say V and K in this order. I can say K and V. Nothing wrong with that, right? K still stands for key. V still stands for V, let's say. Okay? And now I simply say implementation is going to make use of the dictionary over here, and then I say V and K. Okay? Can you see it? Okay? So now, my question is, let's think about, I'm going to write it down. Okay? This answer is over here. If I say database, okay, database table. And then if I say integer and string, okay, integer and string, I'm referring to this particular class. Okay? Now, what would that instantiate the dictionary into? That should be quite obvious to you, right? I just want to make sure. Okay? You can see this is integer and this is string. And we are using, so now V should be string and K should be integer. So it's as if we say string and integer. Okay, that's the exercise we did already. Well, I just want to make sure you're okay with it. Okay, and something similar for the next one. Okay? Okay, guys, any questions? Please. Okay, 2 more diagrams, and then we can go to design pattern. 2 more diagrams. Okay, 2 more diagrams. So these are some diagrams to really illustrate now that you learn about, let me ask you this, right? Just don't let you peek. Okay. So can anybody try to tell me what's the difference between inheritance versus generics? Do you think they are related in some way? Or they are somehow orthogonal or independent aspects of your design? Think about this question. Anything you want to say, that's fine. Generics versus inheritance.
Well, a common feature substitutability, constancy substitutability, you can substitute one for the other.
So that's inheritance or generics?
So for both, when you consider both concepts, for both is this
Well,
principle of substitutability. However, they differ in that one literally replaces the type of what you're saying with generics. However, with inheritance, it has to logically make sense given some ancestor or descendant relation.
Yeah. Typically, when we talk about substitutability, that's really inheritance. When you say I instantiate a generic parameter k by string, we don't say that substitutability. It's not really.
It's very
Okay. Anybody? Yes?
So when you have an ancestor tree in inheritance, the further you go up, kind of the more general it becomes. So it's like the job
The further you go down or up?
up in an ancestor.
Up, yes. The higher it is in the inheritance, the more general it is. So you talk about something more general versus something more specialized in the case of inheritance. I agree. Basically, for inheritance, you're trying to make specialization as you go down of the tree. Okay? If I go from student to resident students, I'm trying to specialize the student with premium rates. Okay? Anyway, that's about inheritance. Generics, since we just covered today, so I'll be kinder to you. Let's look at that. Okay. Think about this. It's a kind of interesting diagram, from your textbook, but I can show it to you here. This one, I'll show you the other one. The other one might be a little bit, the two are similar, just different example. Okay? Let's have a look at this one here. The way to read this diagram is like this. Think about inheritance being the vertical aspects over here. That's inheritance. Okay? When you talk about genericity or generics, you talk about horizontal over here. Okay? The way to see inheritance is, both of you said correctly, you basically talk about either make something more general as you go up of the hierarchy, or make something more specialized as you go down. For example, linked list is more specialized than list, right? Because how can you implement a list? It's more than a linked list option. It can be singly linked list, can be doubly linked list, or it can be different kind of list, right? And then chain is even more general than a list, okay? That's about inheritance. What about genericity over here? Genericity is to say, with the same class that we are talking about, the same level, okay? You can actually change the member type over here. You can parameterize the type for the members, okay? Think about over here, a common usage is you can parameterize the type of members in a collection. And then, as you said, we can actually instantiate the type to different stuff, right? For example, you can instantiate the type to be a person, to be a taxi, or to be a city, right? So basically, inheritance and genericity, they are orthogonal, they're independent aspects, but they work together sometimes. Guys, any question about this diagram here? In case you have struggle. Are you ready for design pattern? Oh yeah? No? Wow, then you're not ready for the project. Yeah, go ahead. Yes. Genericity basically talk about the same class. Okay? You can see over here, we talk about list, and also list. You can also talk about chain with different cases. Okay, let's say the list. And then we are saying that when you declare the list class, you would say class list with generic parameter G. So now G over here may be instantiated into person, in which case every member in the list has static type person. Or it can be instantiated by taxi, in which case every member has a static type taxi, and etc. However, when you talk about generalization and specialization using inheritance, you talk about different classes. Okay? Or to make it even more explicit for you, think about, you talk about some collection over here, and they might take some generic parameter. So here, this is about inheritance. Because you can make the collection class either more general or more specialized, right? And this part over here is about the parameter, right? They're about a type for the member. So this is a generics. another way to see it. All right, design pattern. Somehow, there are two parts for this big story to tell, okay? But we talk about a simpler one today, okay? Let's see how much time we have. Yeah, we have some time. Good. Composite pattern. Let me present to you the problem first, okay? What's the problem we want to solve? I'll present to you the slides, and then we'll talk about, we're going to give you a little bit background information about multiple inheritance, and then we can talk about the pattern, okay? Okay, let's say we try to solve the problem for some manufacturer system for computers, okay? So let's say, basically, this is something we are talking about, okay? You can think about we are trying to, well, kind of like old school style computer system, right? So you got cabinets. Cabinets can store several chassis and also power supply, for example. In each chassis, you can store more components. For example, you can see for the chassis over here, you can store some video card, some hard drive. And also for this particular chassis, you can store hard drive and DVD-ROM, and then power supply, right? Yeah, sorry, it's a bit dated example. Yeah, I should have updated the picture, but it's been used for more than 10 years. Since when I was a student, actually. Yeah. Anyway, so let's say we want to solve this problem over here. Now, can you tell me something? Just by looking at this particular, you can see it's a tree, right? It's not a graph. There's no cycle. Can you see, is there only one kind of equipment over here? Well, there's basically two kinds of equipment here, if you talk about a tree. I'll give you a little bit hints. Fundamentally speaking, what's the difference between a video card and a cabinet? Don't tell me their name. Their name, of course, they are different, right? Just the nature, yes. Car is a component of cabinets, or to add a little bit more to what you're saying, a car cannot contain anything further. However, a cabinet may contain a smaller cabinet. That smaller cabinet might contain another smaller cabinet, and etc. Or make it even more precise. You can say card is more like a basic component, which is non-recursive. On the other hand, cabinets or chassis, they are recursive components. They might contain other things. If you talk about trees back in 2011, you can think about card, hard drive, they are more like a leaves of the tree. And for cabinets, chassis, they are more like internal nodes of your tree. Guys, make sense? Okay, composite is a very general pattern, but we'll just use this particular old example to explain. Okay, let me go over a slide very quickly, and then we'll talk about some background, and then we'll solve the problem. Okay, basically we talk about manufacturing system, and then we got individual equipment, hard drive, CD-ROM, or DVD-ROM. Okay, and now let's say this. Every basic component that is not recursive, let's say they got power consumption and cost, like a price. Okay, let's say they got two different attributes, price or power consumption. And then we also got composite or recursive. So sometimes I might say recursive, sometimes I might say composite. I meant the same thing. Okay. And you got cabinets, you got buses, and also chassis. Okay, so they might just hold other things. So now this is the problem. Can you design a system that will allow us to build a tree-like system, number one? And then can you somehow calculate the total cost for the power, for the price? Let's not worry about power consumption, okay, to make it simple, just the price. I'll give you one example. Let's say this. If you look at this particular one here, let's say $10 for each of the basic component. Let's say video card, $10, hard drive, each one of them $10, DVD-ROM $10, power supply $10, right? Now, if I say now I want to calculate what's the monetary worth of these cabinets, somehow you should really calculate 10 plus 10 plus 10 plus 10 plus 10, 50, somehow. Of course, the challenge is the tree may be arbitrarily complicated. You see what I mean? Yeah. You need certain kind of like a traversal of the tree, somehow. All right. Okay, so that's your challenge. Any idea how to do it? Based on what you have learned so far, including 2011. Any idea how you can do this? You might do it in order traversal, sure. But how do you build a tree, though? Jordan, what you're talking about is how to calculate price. I agree. Somehow some traversal definitely has to be done. But now the question is, how do you build that tree?
Inheritance.
Inheritance. You mean inheritance for the classes? So now, so you have maybe one class for cabinets, one class for chassis, one class for power supply, every one of them. But how do you organize the hierarchy though?
So I'm thinking maybe a container. So cabinet would have the superclass, right?
Uh-huh.
Have a collection. And then, of course, you could have a method that would calculate for each.
I see what you mean. Yeah, that's getting very close. Okay. We'll get to that details. You will see that the actual design is very close to yours. That's good. Okay. So, but don't worry, we'll get to the solution in just a moment. But before we do that, I want to introduce something that's very useful for design: multiple inheritance, which doesn't exist in Java. In Java, you can implement from multiple interfaces, but interfaces does not contain code. They're only signature or headers for the methods. But in IFO, you can use multiple inheritance to reuse code. That's quite handy for design. Okay, so now I'll give you just example for multiple inheritance. So this is actually in the IFO-based library. So you can see under okay, I'll show you here. Okay, let me go back here. So now let's see this. So you can see you got two deferred class, comparable and also numeric. Okay, you can see what is a string. String is comparable only. Okay, but it's not numeric. On the other hand, you can see double class, double over here, is both a comparable and also a numeric. Okay, so you can actually inherit from multiple classes. That's the main thing. That's new. Okay, complex number. They are not comparable, but they are numerical. Okay, that's how you see the inheritance. So now, a little bit challenge for you. Okay, to get a feel about multiple inheritance. Let's say this. Let's say you're designing, oh, some of you are taking 3461, right? Yeah. So now, how would you design something like this for window? The question is like this. Let's say we got so many features we want to include in our design. We got heights, we got width, X position, and Y position. You want to modify the measure, and also for the window. Each window may have a parents, they may have descendants window. For example, let's say this. If you look at the blue window over here, its parent is a yellow window, right? If you look at the yellow window over here, it contains all the other window as its descendants, right? It's kind of like a tree structure over here. How would you design classes for this window? Should you create a Superman class that contains everything? Or does it make sense to decouple them a little bit? Of course, one working solution would be you just put all the features inside a particular class. That's so-called Superman class. It's going to work, but very poor design. Hopefully, you wouldn't do that for your Lab 3. I hope. That's not good. Okay? But for this particular one, any idea? How many classes would you get? I heard 4. Okay, which 4? Well, okay, you said one class for the yellow window, and one class for the blue, and etc.
The ones that are like direct to both, like the dark blue, the light blue, the green, and the.
Well, is it possible to basically you're saying, well, you can think about each window you can see over here. They're basically the same, right? They're similar. It's just that they contain other windows. So why do you need different classes to represent different windows? Yeah, question? Yeah, go ahead.
I would say 2, maybe?
2 classes, or which 2?
Well, one for the whole canvas, which is the big window,
Mm-hmm.
and then each smaller window.
Okay, you're basically trying to group this way. You're trying to say, maybe for the biggest window, like a container over here, that should represent one class of window.
Yeah.
Everything else that might be contained should be another kind of window.
Yeah, but the smaller blue one that contains the other windows is also going to be the same as the yellow.
Yeah, you're still trying to say there are 2 kinds of windows over here, right? I wouldn't say that's the case, because think about the yellow one. There should be nothing that will stop you creating another very big pink window, which will contain everything else, right? So, yeah. But I agree with you, there should be 2 classes. I agree with you. Yes?
Just one class that doesn't contain any window and another class that can contain other windows.
You talk about basic window and you talk about basic window versus recursive window.
Yeah.
Question for you. What about height, width, x position, y position, and change width, etc.? Should you duplicate those features in both classes? You see what I mean? What you're suggesting is this, which I like, not bad. What you're suggesting, very close. What you were suggesting was something like this. Okay, just finish this and then we can see how you can do it quickly. What you're suggesting is, I have maybe basic window. Okay, and then I have another one called a composite window. And then for composite window, I also got, let's say, parents. Also, I got descendants, right? That could be just an array. My question to you, where should I put the features such as height, width, x position, y position? One way to do it, I can put x position here, x position here, y position here, y position here. That would be duplicates, wouldn't it? To really eliminate that, a better one would be, you might say something like, put it here, maybe just window, x position, y position, etc., right? That's another way to do it. Agree? However, that's getting there. That's getting there. I would say that one's not too bad. Okay. Let me present to you something a little bit different. You can see what the difference is. Okay. That's getting very close. But you should see, if you put x position, y position in both classes, that's not good, right? You got duplicates. Okay. All right. Let's now go to the potential thing you can do by multiple inheritance. Let's see that quickly. Okay. Okay. I'll show you quickly, okay, just to get an idea. What we will get is the class we want to inherit to define is called window. And then we say it inherits from two classes. It inherits from rectangle, it inherits from tree. Okay, let's look at rectangle. It's a separation of concern. For the rectangle class, we contain everything about the characteristic of the rectangle. You got width, height, x position, y position, and also change width, change height, and move. Nothing to do with tree structure, nothing to do with it, right? And then we also get a tree over here, and notice that it is generic, which means everything in the tree should be a window. Okay, that's where generic parameter can be handy. And then you simply get a tree of type G, right? So this can be instantiated into window, can be account, can be anything, but for this case, tree, window. And then you got descendants over here. You can also get parents. I'll just show descendants now. It's going to be iterable of G, right? And then we got add, which will add something to the window. It's a descendants. Okay, very simple design. Yes.
So you said the generic type G should be a window, right?
Yes.
However, we can constrain that by actually having that specifically used as an action. Basically, like G is equal to the syntax for window. So would that be making our design to like reproduce on our actual class or information? Would that be good or not?
I'm not too sure. Okay, are you trying to say?
Enforce that constraint on the generic that it should be a window every time, right? Like,
Oh, you can.
then like should we look at that or should we just like?
Oh, you're trying to say the following. Are you trying to say? So here, rather than tree, you would say tree over here, and then G constrained to window. Is that what you mean? You mean like that? Okay, I would say it's a design choice, really. So let's say if there's only one single class that can satisfy this constraint, let's say window. So that means your tree is very limited. You can only store window in the tree. But by making, or descendant window, let's say there's no descendants for the window, right? However, if you make a tree of G, so the tree itself can also be instantiated into something else. Maybe not just for the window, but for other classes. You will see some examples when we talk about the actual composite. Yeah, okay, good. Okay, I just want to show you very quickly how you may use it, and then we'll talk about the design, okay? So now, how can you use it? You can say, I create basically several windows. I got W1 over here. Let's say W1. Okay, it's A6. You just pass the width and height. Okay, and then also you got W2. Yeah. W2 over here, just create different windows. And then you can simply say add W4 into W2. Okay? What does it really mean? It simply means conceptually you are trying to do this. Let's say W4 is here. Okay? I'll just do one for you. W4 is basically over here. You try to create each window separately first, and then you try to construct a tree structure. How do you do it conceptually? You simply say now W4 should now be a descendant of W2. So conceptually, you're basically saying W4 should be moved into W2, right? That's what you're doing conceptually. Exactly how you do it programmatically, we'll see. Okay? This slide here, just to show you, when you define a window class, you can inherit from multiple classes. And each class should be responsible for certain kind of features. Rectangle is only for the geometry. Tree is only for the tree structure. So there are two orthogonal concerns over here. Okay? Any questions? Okay? Exactly how you define those, we're going to see. Exactly. Okay? Yes?
Two blank concerns. What's that word in the middle?
There are two orthogonal concerns. Orthogonal means independence. Orthogonal. If I remember how to spell it, I'll spell it out for you. I could be wrong. Orthogonal. Independence. You can look it up. Yeah, that's fine. It's not important, don't worry. Yeah. It could be important. But. Okay, so now let's talk about one more thing about multiple inheritance, and then we'll see the pattern. Okay? So now let's say this. Do you see any issue over here? Let's say we got A, B, and C. C inherits from A and B. Okay? A has a feature called foo. B has a feature also called foo. At some point, we decide to have C inherit from both. Any trouble here? Exactly. So now let's say if I have a static type of type C, C of type C. When I say C dot foo, which one am I referring to? Am I referring to this foo or this foo? You see the clashing issues here? Okay? So if you, the designer for the multiple inheritance should have thought about this kind of thing. Otherwise, you can easily run into ambiguity for your design. Okay? So now the one way to do it is to say I want to rename. At the level of A, foo. At the level of B, also foo. At the level of C, I have to rename at least one of them to something else. Okay, I'll show you how you can do it. Okay, it's valid syntax in iPhone. You may want to think about it for your project or lab. Okay, sorry, not here. So what you will see is this guy here in the slides. Okay, so now if you look at the slides, okay, see the syntax over there? So we are saying that we have class C inherits from A, inherits from B. After A, we say rename the foo you inherit from A as fog. Also in rename the foo from B as zoo. Yes? You'll get a compiler error, yes. However, as I said, as long as it's possible for them to tell which one you're talking about, it wouldn't be compiler time error. For example, let's say this. If you have none of the two renamings, there's going to be an error for sure. Right? Let's say I remove one of the renaming. Let's say I don't have B rename foo as, okay, let me make it clear. I think that's important, okay? So now let's imagine what I have is this. I say class C inherits A, rename foo as fog. And then I would say B. Do you think that might be an issue there? Not really, right? Because now, when I say C dot foo, what am I talking about? Am I talking about the foo from A or from B? B, right? Because A has been renamed to fog already. So that's not an issue, okay? So now, if you think about this particular renaming, it's going to be fine. So now, when I say C dot foo, it's going to refer to the one from B. When I say C the fog is referring to the foo from A. But I just cannot say foo anymore. Okay, it's kind of straightforward. A little bit test for you? A little bit. Oh, sorry, wrong thing. Okay, let's see this table here. Okay, assuming that we have this renaming here. Okay, let's say we got declared O to be of type A. Can I say O the foo? Yes, right? Okay. Can I say O the fog? No, fog only exists in the subclass, right? Can I say O the zoo? No, because zoo only exists in C. Okay, make sense? Okay, in case you're a little bit puzzled, think about this. O is of static type A, which is over here. For this particular class, there's only the concept about foo. Fog or zoo only exist down over here as a specialization, okay? What about this? If I declare O of static type B, can I say O the foo? Yes. O the fog? No. O the zoo? No. Good. And I'm pretty sure you can predict what's row 3 going to be, right? Oh, no. Can I say all the things? Which one can I not say? Yeah, because now you can see after the two renamings, foo does not exist anymore at this level, either fog or zoo. Any question about multiple inheritance? That's as far as you should know. Okay? It worked pretty much like in Java in some way, right? You just inherit from different classes. You just got to be careful about renaming for clashes. Okay? All right, we got about 10 minutes or so, right? Let's see pattern. Yes?
You have the same name feature but different parameters? Like,
oh, you talk about overloading. Yes. The question was, good question. Remember back in 2011, you talked about something called overloading, right? Overloading in Java. Oh, yeah, of course. Sorry about that. Thank you. Okay, overloading in Java, you can have, let's say, for example, deposit, for example. You say deposit over here, and then you can say string, ID, and also integer, just make it simple, amount. Okay? You can have another one, deposit. It will be okay as long as the compiler can tell the difference, right? So over here, I can say, let's say integer amount, let's say. That's overloading. You cannot, negative, you cannot do this in IFO. They don't support overloading. Unfortunately, what you have to do is just create different names for the feature. Okay? What you have to do is, in IFO, it's more like a design choice they have. Deposit, for example, version number 1, in which case you say 2 parameters, and deposit 2, and then like that. Oh, sorry, just 1. Okay. All right. Any questions?
Kind of a silly question, but when you have beginning there, and you want to redefine also the feature, do we have to explicitly state redefine at the end, or can we?
Oh, yeah, exactly. Yeah, it's a good question. About the syntax, you talk about redefine. You know what? Let me look it up so I can mention that in the beginning. Yeah, I don't want to tell you the wrong information. You definitely can mix redefine and rename under the inherit clause. I forgot the order. I didn't memorize it, but I'm going to look it up for you. Okay? Yeah. All right, so now let's look at the design. As I said before, what I hope you will get, what you will grasp at the end of the course is, when we talk about a design, either good or bad, we don't have to show you the code. We'll show you the design diagram, and then we criticize on that. Let's do this exercise over here. Now, this slide here is going to be more like a summary after we have covered the pattern. I'll leave that at the last, okay? I will go directly to but eventually you're going to see that polymorphism, dynamic binding worked quite nicely for composite pattern, but we'll see. Let's now consider this design diagram over here, okay? I'll give you 1 minute, Okay? This is our first solution. Maybe good, maybe bad. Let's say I just give you this design to say I presented to you the problem for the manufacturer system. Now I give you the solution as a design. I want you to criticize on that. If you believe that's good, tell me why it is good. If you believe it's bad, tell me why it is bad. That's your question. And I gave you a little bit use case over there. Okay? Oh, actually, just think about it for 1 minute before I give you use case. Okay? That's good training for you. And notice a label for client supplier and inheritance, right? Exactly consistent with how you were taught for lab number 1. I'll also make a diagram available to you separately, so you can also see that. Before you can criticize, why don't you try to think in your mind, given this particular design, how are you supposed to create a tree structure like what we presented, right? How could you do it? Of course, you can assume every class has a make feature. Let's assume, okay? Jordan, do you think that may be good? How about this? When we say this design is good, well, how about put it another way? A design would be bad if you could come up with just a single scenario to judge that it is bad. Okay. That's good. We still have time. You got some thoughts? Go ahead. Say that again.
Each equipment is a child, children.
Okay, you're basically asking about the children. Okay, let me help you answer this, right? If you see this, you can see we have kind of like a self loop. We're basically saying the equipment class contains a feature called children. The type is list dot dot. What's dot dot? Whatever class is pointing to, right? That's right. So that means every equipment class has children, right? Can a video card contain children? According to this sign, it seems like you can. Positive. It seems like. Yep, I'm just answering your question. You tell me whether there should be an issue or not. Okay, guys, you follow the thought so far? Your colleague actually just found that according to the design over here, every equipment or every descending classes of equipment has a children feature of type list of equipments. This will be appropriate for composite equipments because cabinet, chassis, and bus, they should have children, right? However, notice that children is at the same time inherited to disk drive and video card. So what is that going to result in? That means I can have a video card that contains a disk drive. Does it make sense? It doesn't make real sense, right? But it's possible by this design. That's how you judge the design is bad. Do you follow my thought here? Okay, let me make it more concrete for you. Okay? But that's good. That's exactly right. Very good. Yeah, I like that. Okay, let me just switch to this diagram here. So if I gave you this question on the exam, this is what I would expect you to justify to me. First of all, explain English words. Why this design is not so good. Number 2, write to me a fragment of client's code and show me why it is bad. This is the kind of client code you can see. Okay? Now I want you to look at this. So now we got CH, we got CRD, we got D. Okay? We got chassis, we got video card, we got disk. Okay? We simply create these objects. Not a problem. Okay? So these 2 lines show the normal usages. You would think that's fine, right? CH chassis.hl card and also ch.add disk drive. So which means I have some chassis objects which has children. Okay, and then it's simply going to be a list of card and disk drive. So that means it's going to be a list. The first one is going to be a card. And then the next one is going to be a disk drive. So far, so good. However, can you just suggest one line to me that's going to make things ridiculous? Aha, exactly. That's exactly what I'm expecting, right? If I say d dot add child, let's say card. How about that? Okay, or crd dot add child d, doesn't matter. Should this line compile? Yeah, it should, because let's see why. It's really important to see why. Static type for D is disk. Is the add child feature defined in disk? This drive, actually. Is it? This drive is over here. Itself doesn't have the children. However, its parent class over here has the children feature, right? Oops, sorry. Oh, yeah, scared. Anyway, so after this, so this will be okay, right? So this is defined in the equipments class. So this design will work if you use it carefully. But we cannot rely on the client too much. We want to be careful, okay? If you've got some crazy clients, which we'll do, try to add a video card into, add a disk drive to a video card. That would be, yeah, not very pleasant, okay? Now, how can we improve this?
Move the add child feature and the children attribute to the composite equipment class?
I agree with you. That's one way to go. That's one way to go. What you're suggesting is, let me try to do a little bit of this. What you're suggesting this is, I like your suggestion, but I'll just do that first, okay? This apparently is not good, agree? Children should not belong to equipments in general. What we should get is, also this one should not be here. We should really put children should be a list of equipments over here, and also add child. And then we got E of type equipments. Guys, agree so far? Now, I would say this is pretty good. However, still not perfect. I'll give you a scenario, okay? Do you agree? First of all, this one will forbid what we just said. You cannot add a video card into a disk or disk into a video card anymore, right? You cannot do it anymore. Now, let me give you one scenario verbally, and then we can give more detail next time. Let's say this. According to your design, children, add child belong to composite equipments, right? Okay. Let's say the following. I have two clusters. One is for equipments. One is furniture. Okay? So let's say over here I got equipments over here, deferred, under which I'll just put one. Let's say cart. And then over here we have the composite equipments, okay, where we got children, and also we got add child. And then under which we got, let's say, chassis. Guys, follow so far? Okay. Let's say for furniture. Let's say here we got furniture. And then what can be basic furniture? Let's say chair. Okay, let's say here we got composite furniture. And then under which we got, let's say, drawer. Would you agree? You should also put children here. Also add child here, according to your design. Any design principle we are violating here? Did you say singleton? Single choice, not singleton. Yeah, be careful. They are totally different. Okay? So now, apparently, we are violating a single choice principle because apparently we're having two different clusters over here, but somehow the composite equipments and composite furniture, they basically got very similar code over there by having children and also add child, just more like an array manipulation. So we have some duplicate over there. So now, how can we fix this? I heard generics, that's good, but how exactly?
Have a parent class and then have both the composites point to that parent class?
Yeah, so we need a more general composite class that can be reused. And the type for the composite can be anything. When I say can be anything, generics, right? So let me draw the diagram and then we are done. Just bear with me 1 more minute, okay? So what we want to have is factor this out into a single class called composite. And then generics. Over there, we got children, which will be, let's say, array of, for example, array of G. And also we can say add child. And then some G over here. So now, how many inheritance should we have over here? 2. This one should inherit from there, and this one should inherit from there. Okay, and these 2 guys can go away. That's the final design pattern for composite. Does it make sense? So now I think what you just said is very important. A very common question was, why do we not simply put a composite specific to the equipment? This is why. If you put another feature extension into perspective, you might have furniture, you might have other things. In that case, you want to reuse the code for composite. That's why you got multiple inheritance, you got generics over here. Guys, any questions about this? Okay, if no, I will see you next Tuesday. Okay.